Good morning and welcome to the first breakout session of MarkLogic World 2018. I'm Steve Buxton, Product Manager for Semantics at MarkLogic. This is my colleague John Snelson, Principal Engineer on the Semantics project. We're going to be talking to you about semantics for data integration. MarkLogic is the world's best database for integrating data from silos. With MarkLogic, you can integrate heterogeneous, overlapping data from many sources for a 360 view of governed data. And MarkLogic takes a fundamentally different approach to data integration. Today we're going to drill down into that data model piece, the multiple data models. We're going to talk about documents and graphs working together and show you how that multi-model approach leads to better data integration. We're going to look at the data models just very briefly, documents and graphs, and then we're going to go on a journey, a 7-step journey from loading your data as is to a 360 view of governed data. And throughout the journey, John is going to be giving you a demo, and the demo isn't meant to teach you how to do this stuff. That would be a much longer session. The demo is just meant to illustrate how easy, how simple it is. So we start with the document model. The document model, that's a JSON document or an XML document. It's a very natural way to model an entity. That's a thing, a customer, an order, a line item, a product, a transaction. It's self-describing. That means it's human readable as well as program readable. And the document model is very good at handling things like hierarchical data, repeating elements, sparse data, the kinds of things that relational databases are very, very poor at. And the schema is flexible within and across documents. What does that mean? It means it's very easy to, quote, just add a column to a document, and you can add whatever columns, whatever structure you want to the very next document you put in the database, and mix it with all the other documents. The structures don't have to match. The graph model is a very natural, simple way to record and query relationships. So we use it to record relationships between entities. So you can record relationships between an entity and an entity and a concept, or a concept and a concept. It's the most flexible data model. It's every piece of a graph is atomic. So it's very simple, very easy to just add a single triple, just delete a single triple. And it lets you do graph-style queries. And we'll see several examples of these as we go through the talk. Show me a suspect in a criminal operation that has this location that's traversing the graph, that's walking the graph. So the graph model, we're talking today about semantics with the big S. So we're talking about triples and graph queries. Just a quick hand poll from 0 is I don't know how to spell RDF to 10 is I have a PhD in ontologies. So where are we with semantics? How familiar are you with semantics? So we've got a 7, I've got a 10 on the stage, some 5s. Oh. Okay, so a few ones, a lot of 5s and 6s. As I've been doing these kinds of presentations over the last couple of years, it's very gratifying to see those numbers grow, that the aggregate numbers sort of grow and grow. For those 1s and the 0s in the room, just a quick recap. The graph model is all about data stored as triples. Triples are subject, predicate, object. An example of a triple is John lives in London. Another triple is London is in England. And those triples just naturally join together to form graphs where the object of one triple is the subject of the next. And we query those graphs with Sparkle. That's a standard language, a little bit like SQL. It allows us to do simple lookups, graph traversals, and things like inference. So I can infer that John lives in England because he lives in London, and that's in England. And these are standards. These are W3C standards for RDF. The Resource Description Framework defines the standard for triples. There's a standard for Sparkle, and there's a standard for named graphs. Okay. Since we introduced semantics in MarkLogic in version 7, we've seen a lot of different use cases. A lot of our customers have had a lot of success with things like semantic search, which we'll look at a bit later on. Metadata hubs for managing assets, particularly digital assets. Content delivery, preparing and delivering very, very rich websites. Intelligence and fraud detection. And the one that we're going to double click on today, data integration. So before we launch into our journey, why do we do data integration? Why not just shovel all our data into a single bucket? We've got it all in one place. Why do we need to do more than that? Well, two things. One is we want to be able to query that data. So we want to be able to query a 360 view of a customer, a patient, a drug trial, a transaction, along with all the entities that are related to that. So you want to be able to find what you're looking for, produce accurate, insightful reports, and also provide curated data to downstream processes, as I'm sure you heard in the keynotes this morning. The other thing is governance. So when you're querying that data, when you're feeding downstream sources, when you're producing your reports, you want to be able to know that the data that you're querying is reliable. You want to know that it's from a trusted source, that it's up to date, that it's secure, that it's fit for purpose. So that's why we do data integration. So step 0, I cheated on the 7 steps a little bit. There's a step 0. Step 0 is out-of-the-box search. So before we start improving on what we've already got out of the box, we've already got the capability to do search. So here we've got 2 customer records. You'll notice that they both describe customers, but they call the fields different things, and they have different structures. We want to find Paul, so we're going to search for all the customer records that contain Paul. And I can do that right away in MarkLogic. You've just loaded the data as is. You've done nothing to the data. The universal index has kicked in because it always does. It indexes everything out of the box. And then right away I can do a search and say, show me all the documents that contain Paul. And that's very much like, if you're used to the relational world, that's like saying, select star from every table where some column contains or equals Paul. Okay? So you've got that right away. Now, what if Paul has variants? What if Paul goes by other names? Paolo, Pablo. He has nicknames. He has aliases. So let's talk about variations. Variations in vocabulary. So step 1 on our journey says, I want to be able to search for Paul, or Paolo, or Pablo, and find all those variants. And the way we do that is we record the variants as triples in a graph. Some people call that an ontology, although that's a scary word that we don't like to use too often. And then show me all the documents that contain Paul or a variant. By querying the triples, querying the graph, finding the variants, expanding the query, and then doing the search. So that gives us select star from every table where some column contains or equals some form of Paul. Okay? So at that point, John, maybe you could show us how easy that is.
I'd love to. So if everything goes as planned, we should be able to switch to the demo box. So let's just look at these 2 customer records. They were on the screen on the slide just now, but I'm about to load them into the database. Just wanted to highlight some of these differences. So property names are different. So we have zip here, and we have postal in the second record. This first record has obviously come from a relational system, which has been a bit inflexible. In the phone number column, there'd only been room for one phone number. So someone's kind of hacked the data model and added an extra phone number in there. Okay, that's a bit messy. We're going to have to deal with that sometime. The second record has got both shipping address and billing address. And it's got 2 phone numbers. So a bit more nicely formatted in this case. We don't have to kind of parse a text field to get those out. But those are reasonably different documents for the same kind of type of information, same customer record. So having just loaded those documents, I can run a simple search like this. So this is the search looking for a document containing the word pool, and we can retrieve the document. So that's out of the box, simple search. But then we can add a little bit of information, this graph that talks about variance in the names. So here we can say we're describing something with the name Paul, and we're saying it's also known as something with the name Pablo and also Paolo as well. So if I add that data, I can then query it. So this query is a Sparkle query, and it does what you'd imagine, basically. It says, I'm looking for someone with a name. I'm going to provide that name so we know what we're looking at. And we're going to follow the also known as links. That means forwards. This bit with the hat means backwards. So we're following them forwards or backwards, any number of steps to find alternative names. And I can just feed those alternative names into a word query, and I can use the synonym option, which says that they're all equivalent words that we want to look up. So this function builds a simple query that can look up both of those, or all of those names. So here we search for Pablo, but again we've managed to bring back the document with Paul in because that search has been expanded using the data that we have. And this is important not just because it helps us with names and aliases, but also with concepts, what other types of information, right?
Right. Yeah. Yeah. Okay. Thanks, Joe. So that's variations in vocabulary. Some people call this semantic search, so we're going to call this the semantic search layer. The kinds of equivalences, the kinds of variants that we normally see fall into a number of different types. So synonyms, another word for trust deed is trust agreement. And I got that straight from FIBO, which is the financial industry's business ontology, which I just pulled down off the web. It's freely available to everybody. There's subclasses. So if I know that every Henley is a shirt, then if I'm running a report about shirts, I expect every record about Henleys to also show up in that report. But there are other kinds of variants as well. And you can get as sophisticated as you want with this. So Joe Smith has an alias. John Matthews is a member of TEHC, which is the Ethical Hackers Club. John Cleese is similar to Peter Cook. And a catheter requires a sterile environment, and that's one of my personal favorites. So BSI, the British Standards Institute, is one of our customers over in the UK, and they realized that people were doing keyword search on their website looking for standards and just couldn't find what they wanted. So they pulled down a medical nomenclature ontology from the web, which told them that a catheter is an implantable device. An implantable device requires a sterile environment. And now if you go to the BSI website and you type in catheter, you will find standards around sterile environments. These graphs can also be domain specific. So you can use one or more graphs at a time to provide a domain specific or a task specific lens over your search. So for example, one of our customers told us that LA Basin is the same as LA area for a particular task. For other tasks, they're not the same. So you can layer these graphs into each of your queries. So why do this with graphs? And people ask me this all the time. Why should I care about semantics? Why do it with a graph? Well, it's flexible. It's very easy to add or remove a single triple, a single variant. The relationships between values form a graph. So as we saw with a catheter, embeddable device, sterile environment. So you want to model them that way, you want to query them that way. And at this point, the data is sacrosanct. We haven't changed the data at all. So when I iterate over the graph, when I start small and I grow the graph over time, I'm not changing the data. And this is a key point, and you'll hear it in a lot of these data integration sessions, is you don't need to do everything up front. Do just as much as you need, build just as much of the graph as you need to improve the search for a particular task, and then iterate over time. And as we said, the graphs can be layered to present domain or task-specific lenses. This also gives you a separation of concerns, so the developer or the guy who's writing the query doesn't have to know other names for Paul or what things John Cleese is similar to. So somebody's working on the ontology, a domain expert is working in ontology, that's entirely separate from the programmer or the query writer. Okay, so that's semantic search. Our next challenge is, how do I search just in zip code? So we know now how to search for 94111 anywhere in a document, but I don't want to find it in a street address or in a phone number. I just want to search for it in a zip code. So let's talk about variations in structure. So here's our two documents again. And again, the two documents have, they both have a zip code. It's at a different place in the structure, and it's called by a different name. So we're going to introduce a semantic query layer. The semantic query layer is two triples. We're going to introduce the notion of a canonical zip. We're going to map the canonical zip to zip for one source. We're going to map it to postal for another source. And then we're going to, we may map other fields for those sources, group them together in a named graph, and that lets us query very specifically for a particular thing in a particular field, whether it comes from source A or source B. Okay. So if you recall when we talked about semantic search, we were talking about better search over what? Over the values, variance in values. Here in the semantic query layer, we're talking about better search over where, or the location, or in relational terms, it would have been the table and column name. So where you're looking for the thing. And we're looking in the same field, so looking zip in this source, postal in that source. And again, the mappings can get much more sophisticated, more complex. We've even seen people include callback functions in their graph. So we can call back from the graph and do some processing to figure out what the variations are. And the benefits of doing this in a graph, again, it's very flexible. When you add a new source, all you do is add to the graph. And the very next query will reflect that change. Again, you can have layered graphs in one place and choose them at query time. The semantic query layer is an artifact. It's a graph. It's something that gets stored in the database. So you can manage it, query it, visualize it centrally in one place. Still, the data is sacrosanct. We've done data integration here, but we haven't actually changed the data. We've only changed the graph. And again, it's iterative. So define triples just for the parts of the sources that you need to query right now and iterate over time. Okay, so that's the semantic query layer. You're going to do this one. So that's the semantic query layer.
I think we're handing over now.
Did you want to show that?
I do. I want to show how to do that.
Okay, why don't you show them how to do that, John?
So I'm going to actually start with our entity services project. This lets you kind of describe your canonical model. So this is the data that we're expecting to be able to see. And it gives you a whole vocabulary to be able to do that. It's not thoroughly important that you understand every aspect of this, because you can always go and read up the documentation, or in fact there are sessions on entity services later on today. But we're defining our customer, and we're saying it has various properties. So it has ID, family name, given name, an array of addresses, an array of phone numbers. And we can add that description into the database there. And right at the start, that's been indexed, and we can actually view that as triples now. So it's used our TDE functionality. And we can run queries, Sparkle queries like this, that say, well, tell me about the property, the zip property, and the number property. And we can find out some information there from the canonical model. Things like the data type. It's expected to be a string. But then we can also extend that model. So it has been built to be extended. And so it's a good place to start when you're going to build in new functionality. So I'm extending this with my own data model. And I'm inserting data that describes where these properties are found in the various sources, like we were talking about in the slides. So for source one is stored in a certain collection, and it implements this particular type of entity, so a customer, at a given path, and the property for given name you can find by navigating to the fname property, for instance. So there's source one described here, and then source two is described, and for given name, so it has a different field name. But we're actually going to do zip code, so that's down in the address area, so here postal. So I can add that description in, and then I can perform Sparkle queries against that description. And I'm now querying over both the model and the extension to the model which I just added. So this query, it has a few components to it, but basically it's going to return me properties and the paths where I find the information for that property. So let's scroll down and find zip code here. So we can see that zip code in source one is just in the path zip. But for source two, we have to look in billing address or shipping address / postal. Okay? So we've got that information available to us. We can query for that, and we can do a couple of things with that information. I'm going to use this query here to iterate over those rows that I just returned in that query. I'm going to add a path range index for each of those rows. So if I go ahead and do that, that will cause the data to be re-indexed. And you can see a description of one of the indexes I just added. So that's on source 2, billing or shipping address / city. So that's the city index. But having indexed those, we can then query one of these properties. So this is exactly the same Sparkle query that we just used to add range indexes. But now I'm going to fix the value of this property field by passing it in as an external binding. So that's happening here. And basically what we're doing is we're running an OR query over a path range query for each of those paths that the Sparkle query is returning us. So we're just saying look in shipping or billing address / postal, or look in zip. So when I run that property query and I'm looking for zips that are equal to 94111, it will go ahead and do that, and it's returned us both documents because this one has it in the zip field and this one has it in the shipping address. So we've managed to look across both of those types of structure just with a bit of metadata and pre-processing of our query before we run it.
Okay, excellent. Thank you, John. So I asked John to show you how simple it was to do the semantic query layer, and like every good MarkLogic engineer, he massively over-delivered and talked about the canonical model, because that semantic query layer was based on a canonical model. So let's talk a bit about canonical models of entities. So a customer, a product, an order, and so on. If we know all about the zip and the postal, we want to collect all those together and have a collective model of everything we care about in a particular entity. And the entity type model is part of entity services, which we introduced in MarkLogic 9. It's a suite of services and helpers and tools to help you model entities. An entity is defined as something that has properties and relationships. And the entity type model, as you've just seen with John, is made to have a fundamental core and then to be extensible with triples. So as you add triples to that model, you can extend it to do whatever you want with it. Often we see it used for governance and provenance, that kind of thing, but you can extend it to do anything. So how do I create an entity model? I create an entity model descriptor, which is a document, normally a JSON document. I can create that manually and just insert it into the database. It goes in under a magic collection, and then we know that it's an entity type model. I can do it in a GUI if I'm running the Data Hub framework, which you'll see in other sessions. And that model descriptor gets automatically indexed as triples. So now the model can be queried as a graph and also as a document. And once you have that model, you can auto-generate a number of different artifacts, such as indexes, as we saw from John, some stub transformation code, security, and so on. So what does it look like? This is the customer entity model as JSON. Here's the result of a query across the model using Sparkle. And here's a prettier way to see the model as triples, as a graph. Okay? So because the model is available as a graph, you can do those graph-style queries. Things like, in the customer model, show me the name and description of each property and its properties and its properties and its properties that is range indexed. You can link it to other graphs and do graph-style queries across those graphs. So for all entities that are a subtype of person, show me the name and description and so on, and is subject to business rule X from this graph over here, or security policy Y from this graph over here. And you can easily extend that model just by adding triples and linking to other graphs. Okay. The benefits, again, these are the benefits of having the model available as a graph. It's very flexible, easy to change and extend. It's written down in a single place. It's centrally managed, versioned, secured, queried. And we can create entity instances and other artifacts, and it can be used to create services. So when I'm doing that API first thing, when I'm creating my next API, the first thing I'm going to want to do is look at the model. Next challenge. I want to query over transformed data, but I don't want to change the data. So this sounds like magic. How am I going to do that? So let's talk about querying transformed data. And the way I do it is I transform not the data, but the index. And so I can transform or manipulate that data as I index it. I can actually break into the indexing process. So for example, pull out the phone number from a complex field. For example, the source has first name and last name, but I want the index to reflect full name so that I can query against full name. I can manufacture data in the index, so I can fill in missing values, default values. I can fill in pre-calculated values. And the way to think of this is, we've talked about query level integration in a couple of ways: semantic search, semantic query layer. we'll move on to talking about data level integration, and this sits right there in between. So query level integration is the most agile, the most simple and easy to change. Data level integration is generally going to give you the very fastest queries, and this is somewhere in between. And we can do this, we can influence what the index says about the data by the magic of templates. And in MarkLogic 9, we introduced template-driven extraction, TDE. And the general idea here is that you write a specification, you write a template that tells you how to project out of a document into triples, and for that matter, into tuples. And that lets you query that projected data with Sparkle, and by the way, SQL, and MarkLogic's Optic API. And the Optic API, for those who haven't played with it yet, can query across documents and graphs and tables. So John, is that simple?
Oh yes, that's so simple. So we're going to take the example of the phone number field that we looked at earlier. Remember that the phone number field for one of the sources has kind of been jammed two numbers into the same string field with a bar to separate them. So we're going to need some amount of processing and function calls and things to be able to actually access that. So this data I'm just about to add, this is going to extend the descriptions that I put in earlier to talk about how to deal with phone numbers. So in one case, we need to call a function and tokenize it and split out the numbers. And in the other case, it's fairly simple. We're just going to look under the number field to find the number. But we can do that, but we can't make a range index that calls a function. What we can do is make a template, a TDE template that will do that. So this is slightly longer, but let me just talk you through the bottom loops. So we're going to create a template here. We're going to loop first over the different data sources, and we're going to create one template for each type of source that we're dealing with here. Then we're going to loop over the entities that are inside that source, and we're going to output more of the template. And inside that, we're going to loop over each property for each entity in each source. And we're going to output a template for a triple that reflects that property. So if I add that template, that's all been generated from the semantic data that we added to the database. And as I speak, it's going to be re-indexing the database. Only 2 documents, but they're going to get re-indexed. And so now I can do a search, and I can target the triple index, because we added triples to the triple index. And so now I can target the triple index and say, well, I'm looking for triples which have an object value of 415555. In fact, I can change that to be the phone number IRI. That's just that variable up there. So we're looking for the phone number that is equal to that. And there we go. We get back the document. But we searched for just that phone number. But it's returned it even though it's in a complex field, because the index reflects the individual phone number that was pulled out from that complex field. I mean, that template didn't just allow us to use triple range query. It actually put a whole lot of information into triples, and those are available now from Sparkle. So if I wanted to query for addresses that were in San Francisco in the USA, I can do that. And it will come back and tell me the streets for those and the types of addresses that we've got. And that's an address from each of the different sources that we just saw. So the templates have been used to be able to have a single way to query the 2 or more different sources of information.
Okay, cool.
Right, that one.
You shouldn't ever trust me to press buttons.
No.
Thanks, John. So, we've looked at index level integration. We've looked at breaking into the index and project things out of the document into that index. Next, the next step on our journey. Parts of my model at this point are stable, and I want to push that down to the document. So up until now, we've been very agile, very flexible. Now I'm going to start changing the document. And we're going to talk just a little bit about harmonizing documents. Not much, because there are a lot of other sessions on this during the conference. But at this point, we want to push down those model changes to the documents. This is the most flexible in terms of the transformations you can do, because those transformations are in just ad hoc code. It's the fastest to index because you've actually marked up the document, you've annotated the document. And the queries are simpler because you're querying directly against the document. You're not going out to a graph, expanding the query, and then going against the document. And it's nice for visibility. So all your data is there together. You look at one document and you've got all your canonical data and your raw data. And MarkLogic's approach to data harmonization is to take documents from different sources, heterogeneous, overlapping data, harmonize them into an envelope document. It's called an envelope document because you're taking the source, you're wrapping it in an envelope, and then you're promoting the canonical transformed data into the top of the envelope, and you're keeping the rest of the data, the raw source, in the bottom of the envelope. So here's what that looks like. Here's an envelope document in JSON with the entity type info at the top. So that's metadata about that entity type, about customers. The harmonized canonical data and the raw source data, because you always want to have that raw source data available to you. Okay, and that's all I'm going to say in this particular session about data harmonization. So how do I know I can trust the data I'm querying? So where did that data come from? So in step 6 of our journey, we're going to talk about provenance. And who knows what provenance means? Is that a familiar term? A few. So provenance is a fancy word for knowing where stuff came from. So we're going to add a provenance graph to an entity. Provenance tells me where this entity came from and where that came from and where that came from. And so it's just very naturally graph shaped. And the kinds of queries you want to do over provenance are also graph style queries. So here's our provenance graph. Remember, we've done our transformation now, but somebody comes back later on and says, this transformed document, where did it come from? Who made it? Who approved it? When was it done? What documents did it come from? So we have a provenance graph made up of the envelope document, the process that generated it, the document or documents that went into that process. And I can do a couple of things here. I can imagine that each of these has its own provenance graph as well. So this document came from this came from something else, came from something else, came from something else. And I can also link it very easily into other graphs. So I can say that this harmonization process was approved by Jane. Jane is a senior data scientist. She's in engineering. So I can do queries like, well, maybe we found out that Jane is an unreliable character. Show me everything that Jane approved between these dates. And everything that was affected by them, as many steps as you need to take. Okay, so.
I suppose you want me to show you how to do that?
Yes, why don't you show us how to do that?
Right, so what I've done is I've used entity services here. One of the functions of entity services, the suite of tools that comes with it, is it can spit out a generic transformation query for you. It's kind of a fill in the blanks thing. There's a few places it directs you to where you add the code that you want, and then it will transform your documents into the envelope. So you need to do that, have one of these kind of modified queries for each of your sources. So this is the function calls. They're going to do that. They're going to transform it into a canonicalized version of our model and add the envelope document to the database. Well, whilst we're doing that, we're also going to add some provenance information into the graph as well. And we're going to talk about when this envelope document was generated, where it's come from, what sources it comes from, and what model was used to do that transformation as well. So I can go ahead and add that information to the database. So that's transforms the first source, and this is a very similar query that transforms the second source of data. And immediately that means that we can query those, because they're now the same format. The canonical data is the same format, so we can easily query that. In this case with xquery, now looking for our document with that same phone number that we looked for before, but we get back the canonical version of this data now. I've just looked inside the document and taken just the canonical part, but there you can see the information. And that record, that source, the first source, which had oddly named fields and a phone number in a composite string fields, it's all been pulled out and made nice, basically. And now we've got a much easier to query artifact. If the queries are simpler, then executing them is going to be faster, basically, as a kind of rule of thumb.
But you do still have the original information in there, though, right?
Right. Yeah. I mean, if I just show you the envelope instead, like this. So there we go. Let's say I'm looking for the same thing, but not looking for the same thing. There I am. So I looked for the same thing, but now I just didn't look inside it. I returned you the whole document. So now you can see the information about what the model was, and right down here at the bottom you can see the original document there, still attached, still available to do further work on it, in your next kind of agile sprint or whatever you might be doing. One of the other facilities that Entity Services gives us is the ability to generate a TDE template that works against that canonical model which it's now generated. So this is quite a long template, but that was all just generated by those two function calls. Sorry, let me show you them again. One function call. So if I add that to the database, that then gives me a number of possibilities. We can query that with Sparkle, but just for a bit of flavor, we can also query that with SQL, and it creates views which are only present in the index, which we can then query, and the same data is now available in multiple places. But thinking back to where we started, when we did these transformations, we added provenance information, and as we kept track of what we did, we can now query what was done and talk about maybe what's the most recent data. In this case, it's actually looking for things that are generated from a particular model, and there's a time constraint, although that's due to the constraints of doing this demo, the time constraint is not very interesting, but things that were generated before now using that model. But there you can see the document URIs for what was generated and the time that I generated those. And of course the potential there is for all sorts of error correction and investigation into processes.
Excellent. Thank you. So, thanks, John. So John showed you an awful lot of stuff there. He showed you the entity model. He showed you the entity model generating artifacts, such as a template. He showed you using the entity model to do data harmonization into an envelope pattern document. And because we're changing stuff, we want to track that change. So he also showed you provenance, recording the provenance as we make the change. So until now, we've talked about querying across customers, a single entity, and I'm sure that's been fascinating. But even more interesting is querying across entities. How do I query? How do I link a customer entity to an orders entity, for example? So the 7th step on our journey, linking entities. Let's talk a little bit about that. And we're going to talk about that really just in terms of a summary diagram. So here's my customer, customer 1. We know this customer has a model, cust 0.0.1, the one we've been playing with so far. We know that he can be linked to a provenance graph. So that's the graph of all the changes that were made to that customer record. He might also have something like a usage log. So a usage log fits more naturally, more easily into a document. And we link that usage log to the customer with a triple. We've also got a materialized view of the customer. So we've got Business Joe and Casual Joe. And our materialized view also has a model, has its own usage log, has its own provenance graph. So in addition to that, we can now link Customer Joe to things like a credit summary. Again, it's just a triple. The credit summary is a document. We create a triple linking the customer to the credit summary. We can link him to a product. And maybe our product is represented as a graph because it has part numbers and components and associations to vendors and manufacturers and so on. And so what we've got is we've got semantics everywhere. Rewinding all the way back to the title of the talk, semantics in data integration. We've got semantics in the model, which you've seen. We've got some of the artifacts here are documents and some are graphs. And then we have semantics just linking them all together. We have triples linking them all together into a queryable graph. Okay. So the semantic model that we got from entity services, we used to generate code to transform from raw source to an instance of the model, to generate templates, to expose data as triples, as SQL views, to generate configuration settings such as indexes. We saw some range indexes being created, and to generate things like REST endpoints for APIs. When we extend that, we can extend it to create provenance graphs, links to other entity instances, usage logs, security settings, and things like special purpose materializations. And just a quick plug there, links to other entity instances. There's a talk this afternoon on the Data Hub framework, and they use these links extensively. And security settings, there's a talk at some point on PII, personally identifiable information, and that's been introduced into the entity model just in the last version. Okay. So to summarize, our 7-step journey, 8 if you include the 0. We started off with data loaded as is and out-of-the-box search for something anywhere. We added an ontology, we added a graph. Then we were able to do semantic search, so we can search over variations in what we're looking for. Then we introduced the notion of a semantic query layer, another graph that lets us do query-based integration. It lets us use the graph to figure out where to look for the information. We added an entity type model. That's a centrally managed queryable model. That let us generate a template for index-based integration. If you remember breaking into the indexer and putting things in the index that aren't explicitly there in the document. We harmonized documents, so we moved on to document-based integration because our model was stabilizing, it was maturing, and we were pushing things down into the document. We extended the entity type model for things like security and provenance. We saw provenance here, PII you'll see in another session. And we saw the opportunity to add things like special purpose materializations and again link those back to the original entity. And the little red line this is where we start changing the documents. So you can do everything up until the red line in a very agile, very iterative fashion before you even start changing the documents themselves. Okay. Okay. Any questions? Yes.
So hang on, there's a microphone just going.
Oh. Do you want to shout it out while we're getting that arranged? Yeah. Just shout it out.
Oh, the index-based integration. Oh. For the index-based integration example that John was showing, I just had a question more about implementation specifics. So when you're, there was the tokenization example, right?
Right.
So you projected some triples from the input document. Mm-hmm. So my question was, first, how in a workflow where you're ingesting data repeatedly, one, how does it work specifically to ingest more data and continue to project those triples? And then also, where are those triples once they go? Like, where are they in the database?
Yes. Okay. So TDE allows us kind of a convenient mechanism to be able to look at a regular document and describe how to pull some triples out of that. So we may have, fixed constants or predicates, but we may pick out object values from the data. Or like you were seeing, I actually ran a function to take part of the string and put that as the object value. So those triples just exist in the triple index. They don't get manifested in the document in any particular way. That happens automatically. So once the template's in the system, registered as a template, any new documents that come in that match the criteria for that template will be indexed using it. And that happens transparently and transactionally, so that as soon as the document's in the database, those triples are also available to be queried. But those triples are forever linked to that document in such a way that if you can see the document, you can see the triples, but vice versa, if you can't see the document, you can't see the triples. And if you delete the document, the triples go away. So it's as if you had kind of used our special triple format to put them into the document, but they don't actually need to be present in the document. They're just in the index.
Thank you.
Another question in the back.
Very quick one. Are you going to share that workspace with us?
That is a good question.
Yes, we'll figure out a way to share the workspace.
We got scanned at the entrance, so you have our emails. So if you add the presentation as well, that'll be appreciated.
The talk will be made available in audio on the website.
Right.
And we'll publish the slides with that, presumably.
Yeah.
So we'll try and add it to the website alongside those other artifacts.
The workspace is quite interesting, and it was really hard to follow on the screen.
No, absolutely. Right. It was too quick to really understand all.
Thank you very much.
Okay. Any other questions? Yes, at the front.
How do you connect with
Hang on, there's a microphone.
So do we have any process to connect with the advanced analytic tools like Power BI or like Tableau? Tableau I heard on MarkLogic, especially with the Power BI.
Yeah. So you saw John do a SQL query. So that same template that can project triples out into the index can also project rows out into a SQL view, again just into the index. And if you want to use something like a Tableau or a Power BI, you can connect through a SQL ODBC driver and do those kinds of SQL queries. Yeah. Or you can. We also have something in the DM SDK, the data movement SDK, which will let you create a Tableau data extract. So you can move data from the MarkLogic database into a Tableau format.
Yeah, not tried with the Tableau, but tried with Power BI. Like, it's always a kind of getting hung. Not data, like, MarkLogic has a driver for the Power BI, but it's not working.
MarkLogic has a
driver, ODBC driver for the.
So we have an ODBC driver. Let's talk afterwards. I've run Power BI against our ODBC driver and it's worked. So let's talk afterwards. See what's going wrong. Okay. Yes.
So in relational to the Data Hub framework, does part of the work discussed here fit in the framework or happen outside the framework or before the framework or workflow?
So it's all part of the Data Hub framework. So what we've been talking about mostly is how the underpinnings work. The Data Hub framework is a nice way to wrap all that together and give you a GUI and make things simpler for you to code up. But this is all stuff that's happening underneath the Data Hub framework.
So for that, do you mean we need to do this work before we use the harmonization flow, or this is something that will eventually become part of the flow?
So you can bring up the Data Hub framework. You can create a harmonization flow. One of the things you can do in the harmonization flow is you can add triples. So there's a plugin that says part of this flow I want to add triples. Otherwise, a lot of what we've talked about will happen under the covers as part of the Data Hub framework. Okay.
Any other questions? Okay. Thank you for coming, being part of this presentation. Lunch is served.
Okay, thank you.